And we got negative 923 plus negative 487. And since this is already addition, there's no need for keep change on this one. That's what we always want is addition. So you got a negative 923. It's a negative, but you're going to make it more negative. That's what the plus means. More negative. Okay, which means that when I combine these, I will certainly get a negative value. But how negative will it be? Well, you're going to have 923 of those negatives, and then combine that with 487 of those negatives. This will tell you how negative it will be. In the ones place value, 3 plus 7 is 10. Carry the 1. 1 plus 2 is 3, plus 8 is 11. Carry the 1. Now the hundreds place value, 1 plus 9 is 10, plus 4 is 14. So that's how negative it would have been, negative 1,410. And that would do it right there. All right, there's our objective for today. There's 3 things we got to be able to do by the end of this lesson. You need to identify any place value that we ask for. You should be able to round it to any place value that we ask. And then finally, you should be able to order any value or compare values together. So take a minute and copy these down, please. All right, so place values. Place values is what makes our number system not only unique, because I think pretty much all of them are unique, but it also makes it very easy to do calculations, to perform calculations, okay? For example, if you went back to ancient Rome, they'd say, well, somehow v plus v, that's 5 plus 5, is x. I don't know how the crap that happens, but it does. Or even worse, you could say 2, right? If you showed it like this, 2 plus 2, somehow IV. I mean, you can figure out how that works, but I don't understand it. And it would be very difficult to be like, well, look, you're going to take 1,000 and then plus, I don't know, 3 like this, and you get 1,003. Okay, that kind of makes sense. But this other stuff where they start to change the letters, that's where it gets a little freaky. And of course, you could go even further back and say, well, yeah, let's do tally marks and say, well, you got 2 tally marks and I got 3 tally marks. If we add those together, somehow it's 5 tally marks. Okay, and that works. But it only works usually in terms of practicality for smaller values. Once you start looking at larger values, then it doesn't really make a lot of sense anymore. Like no one really wants to do 1,000 marks, 1,562 marks plus 928 marks. Yeah, that take a long time, not just to do the calculation, but to actually add the marks together. And then when you combine them, you're just repeating all that together. Okay. Or even worse, perhaps kind of the dot system, right? Like 5 plus 6. Yeah, then you get 11. And I don't really understand how you do that, I guess. But I guess I can try something like this. Anyways, you can see that would be very difficult, whereas in our number system, if you did, well, let's do 5 plus 6, right? 5 plus 6 we know is 11. You can carry the 1 over if you need to. Like if that was 15 right there, you'd carry the 1 over, then you say, that's how many 10s you have. 1 and 1 10, that'd be 2 10s right there, 21. So that, again, that's what makes our place value system so nice. Not that I think anyone necessarily likes it, unless you're a math nerd like I am, then it's pretty cool. But it does make calculating a lot more easy than to say v plus v is x. So in our place value system, of course, we're looking at whole values. And you got ones, tens, hundreds, and then these 3 repeat by period. Okay, so there's just the base ones, tens, and hundreds. Then after that, 1,000s, 10,000s, 100,000s, and then you can go into millions and billions and trillions, okay? And I put ones on these. You wouldn't necessarily have to do that if you were to answer a question on Canvas, but I like to show that it's a repeating of our base period right here, okay? Now, if you look at this thick black line right in the middle, that represents a decimal, okay? Now, everything to the left is its own place value, and I'm putting these as blanks. Of course, in the future, you'd say you're going to fill these in with actual numbers, okay? And every third value is, you could say you can put a comma in there, okay? At least if you're going to the left. Well, going to the right, this gives us partial values, And so the next place value here would be tenths, then hundredths, and then thousandths, 10,000ths, 100,000ths, millionths, 10 millionths, 100 millionths. Now you'll notice there's no oneths. That's because oneths would just be ones, just like right here, okay? So you start with 10, but you'll see that everything to the right of the decimal has the THS. That's crucial. And while I'm going to emphasize these, you may not want to do that so much when you're speaking these because you're going to spit all over everyone, okay? So tenths, hundredths, thousandths, and then you see the thousandths, right? We're in thousandths. There's three of them. You could say 1,000ths, 10,000ths, 100,000ths, and then so forth, okay? But you do need that THS when you're writing these out so that we know which place value you're talking about. And again, that's only to the right of the decimal place. Now, if by chance you have empty place values, let's say 20,406. Okay, now this would write, you'd have 2 in the 10,000s, 4 in the hundreds, and then 6 in the ones. So that would indicate that we don't have any thousands or tens, and that's when you put zeros into those place values. So again, with most other place values, there's no other way to show zeros like this than empty place values, but with ours there is. We can just use a 0 right there, okay? And that would go even into the decimal type place values. All right, ordering values with decimals. So we got to separate positives and negatives. You're going to order the negatives from least to greatest. And even on the homework, when it asks for you to order the values, you're always going to do it from least to greatest, okay? Now, the negatives, the bigger the negative, the less value it has. And let's look at kind of an extreme case here, okay? So let's say negative 10,000, and we'll say negative 5 like this, okay? Now, the question is, which of these has more value together? And sometimes it helps for students to see these with dollar signs, even though we're just comparing these numerically. So the question here is, and the negative indicates owing. Would you rather owe someone $10,000 or would you rather owe someone $5? In fact, if we made this more profound, it'd be like, man, if you owe someone $100,000, maybe the mafia is going to get you someday, but negative $100,000, would you rather owe $100,000 or owe $5? And really, we hope the answer is neither. But if you have to choose between the two, because it's math, mental abuse to humans, so hopefully that would be the negative 5 right here, okay? Because you would want to owe less. So you can look at this in terms of money. Another way to look at it is on a number line, which I think most everyone is pretty familiar with. If I put 0 right there, negative 5 would be this mark, and then we'll say negative 100,000 over here. It's not proportional, and I also don't care. But you'd see everything to the right of 0 is positives, and everything to the left of 0 is negatives. And the further to the left you go on the number line, the smaller the values are. The further to the right you go on the number line, the bigger the values are, okay? And so I can see clearly, if I were to graph these on a number line, that negative 100,000 is further to the left than negative 5. So if the money thing helps you out, use it. If the number line thing helps you, then use it. And then when you order your positives from least to greatest, you compare these one place value at a time, which we will show, okay? And then you combine the two lists. So that's what we're going to do on the next problem. Here we got some values. Looks like 8 thousandths, 403 thousandths, 47 thousandths, 3 thousandths, and then negative 34 hundredths, and then the next one negative 3 hundredths. Now, if by chance, and this is hypothetical because it's not part of this problem, like sometimes students get these two mixed up, negative 0.2 or 0.2 and 0.02 like this. See, if you need to tack on zeros to the right of values, you can do that. They were there the whole time. This is called the phantom zero. It was there the whole time, you just couldn't see it, which kind of makes the phantom values creepy. They're always lurking in the shadows. But now I can see I'm comparing really 20 with 2, like that. Okay, now that's a hypothetical, but if you saw something like that, it may be helpful. Now, like we saw in that last slide, the first thing I'm going to do is just look at my negatives first. So I got negative 0.34 and then negative 0.03. So I'm going to write these out. Negative 0.34 and then also negative 0.03, okay? Now, which of these is bigger? Well, they're both in the hundredths place values, and they're negatives, though. So, to find the one that's the least, we would have to figure out which of these is the most negative. Well, 0.34 is more negative than 0.03. Again, that's 34, that's 3, as long as I'm comparing the same place value, okay? So if I wanted to list these in order, actually, that would be in order from least to greatest right there. Now, another way you could do this is you could say, well, I'm going to compare these by place value. So if that were the case, you start with the place value furthest to the left, which is, in this case, zeros. If they match, you go to the next place value to the right. So the next one I would look at is the 3 and the zeros. If they match, then I would continue, but these ones don't match, so I can compare them. Is 3 bigger than 0 or 0 bigger than 3? Well, 3 is bigger than 0. Now, the reason why that's important, because this is negative. Since 3 is bigger than 0, it means it's more negative. It has less value, okay? So this is in order already from least to greatest. Now, these other place values. Okay, so let's go ahead and write these out. Actually, I use some technology to do it because it's convenient. So these are all my positive values right here. Now, with positive values, we compare these by place values as well. And we can see all these place values. So I start as far to the right, as far to the left as I can go. And what do I notice with all 4 of these place values? That's the ones, or the whole place value. They're all zeros, which means I need to go to the next place value. So that'd be this 0, the 4, this 0, and the 0, okay? Now, the only one that's different is the 4, and it's bigger than all 3 of these zeros, which means that of these 4 values, 0.403 will be the biggest one. So I kind of use that one. I'll cross it out. But I'll continue with these other place values. So now the hundredths, and hundredths. Okay? So there's my third place value I'm comparing. 0, 4, and 0. 4 is the bigger of the 3, because the other 2 are zeros, which means it would be the next biggest. Now, I'm listing these from least to greatest, so I'm going to put it to the left. 0.047. And that one is used. Now, I will compare the 8 and the 3 in the thousandths place value. And which one's bigger? The 8 is, which means that it would be next in the list, in this list that I have. So I guess I kind of went backwards there. And then 3 is the smallest of the 4. Okay, and again, 3 is smaller than 8, which means it's the smallest. So this is already in order from least to greatest, even though I kind of did it from greatest to least, going backwards here. Now that I have my list of negatives and my list of positives, all I got to do is list these out. Here's my negatives. Here's my positives. And I'll separate these with a comma to be efficient. Boom. So I just listed these in order from least to greatest. Again, start with your negatives, then do your positives. And keep in mind, too, and this is, again, kind of a hypothetical, but if you compared values that kind of look the same, like even this 0. Let's make this 4.5. Some students would say 0.405. And so you'd say, well, which one's bigger? Okay, well, see the 0 matches, the 4s matches in the tenths. But see how the 5 in the hundredths and the 0 in the hundredths, they're different. That makes this one bigger. All right, here we go. Same thing on this. We're just comparing 2 values. Now, we don't care. I'm not so concerned that you know that this one's less than or greater than or equal to. Because usually in elementary school, they say each the bigger one. Whatever makes a difference to you, that's all that matters, okay? So we'll make it eat the bigger of the 2. And again, we compare these by place value furthest to the left, okay? Now, right out the bat, I see in the 1's place value, you got zeros. They match. So I move to the right here. Now there's a 3 in the tenths and a 3 in the tenths. Those ones also match. Moving further to the right, I get a 7 in the hundredths and a 0 in the hundredths. Now they don't match, which means that really I'm going to ignore anything to the right of the hundredths place value. Doesn't matter what they are or how many of them there are in the decimals. So which one's bigger, 7 or 0? Well, hopefully we know by now that 7 is bigger, which means that this should eat that 0.3706, okay? Now again, some of you'd say, well, this number's bigger because it has more numbers. No, it doesn't matter how many numbers there are. It's by place value, and that's, again, the unique thing about our place value, okay? Now, just so you know, this is the greater than symbol. The other one, this one's less than. I don't know. We'll talk more about those in a future unit, though. I just want to emphasize this again because some students still get this mixed up. It's like, well, that's 3,706. This one's 30,706. Yeah, but by place value, this is 3,706 10,000ths. This is 30,706 100,000ths. It's a smaller unit. All right, then we got rounding. Now there's nice little rounding rhymes on YouTube. You can look those up, and they'll sing it for you. I think you can find pretty much any music genre out there, whether it's country or rap or Sesame Street, whatever it is that you like, okay? You can look it up on YouTube. And no, I will not be singing for you. But first thing we're going to do is underline the digit. Now, when it says the digit, we're looking at the target place value, okay? That's the one that we're specifically going to underline. Then it says look next door. When it says look next door, we are specifically talking about looking to the right. So that's to the right. Boom. Now, if the number to the right is 5 or higher, you add 1 to the target place value, okay? If it's 4 or lower, you just pretty much make that anything to the right zeros, and your target place value just stays the same. Now you can see this rhymes because there's so many rhyming schemes for it. Underline the digit, look next door. If it's 5 or higher, add 1 more. If it's 4 or lower, just ignore. And there you go. If you want to make a little tune to that, do it somewhere else. But in any case, okay, so I do this a little different. I do underline the digit. I look to the right. I will circle the number to the right, so I know it's the one I'm looking at with these two conditions. If it's 5 or higher, I add 1 to the place value that we're targeting. If it's 4 or lower, I keep that place value the same, and then everything to the right becomes zeros, or we just ignore it. All right, let's round this one here to the nearest 10,000th, okay? So let's make that a little bit bigger. Let's identify where that place value is, okay? 10, where's the 10,000ths? Well, that 2 is in the tenths, 8 is in the hundredths, 9 is in the thousandths, and then the 2 there is in the 10,000. So I will underline that. Now, like I said, I will circle the number immediately to its right. And this is the number I'm looking at to compare, okay? So I see I circled 9, and then I ask, is 9 5 or more? Now, 9 I know is 5 or more, so the answer to that one is yes. Okay, since that is the case, I add 1 to my target place value, which in this case is the 2. So I take the 2 and I add 1 right there. And then what do I get? 2 plus 1 is 3. Now everything to the left is just going to drop. The 9 will drop, the 8 will drop, the 2 will drop, even the decimal and the 0, okay? And then everything to the right, we just ignore it. Just ignore all that garbage. Anything to the right is ignored now because these would become phantom zeros. And what do we do with zeros? We ignore them, which is unfortunate, but we do that even with our humans, okay? So zeros we do ignore, which means that this would be our final answer right here, okay? That would read 2,893 10,000ths. So this time I'm going to do the same thing, but now instead of the 10,000ths, I'm going to do this purposefully, by the way, because you will see it. Instead of the 10,000ths, let's make this the 100,000. Yeah, let's round this to the nearest 100,000ths. And so once again, and this is where some confusion happens, okay? So 100,000ths, let's underline the place value we're looking for here. So tenths, hundredths, thousandths, 10,000ths. The 9 is in the 100,000ths, okay? So I circled the number immediately to its right. Let's see if I can circle that better. That's a little better. Immediately to its right there is a 7. So again, we ask the question, is 7 5 or more? And the answer to that one is yes. So we add 1 to the 9 in the 100,000 place value. And this is what happens. So 9, we're going to add 1 there. Okay. So 9 plus 1 is 10. So here's what happens. 9 plus 1 is 10. I get the 0, and I got to carry the 1 over into the next place value. That's the 10,000ths. So that's a 1 and a 2, which would make 3 there. And then the 9 would drop as a 9. This 8 drops as an 8. This 2 drops as a 2. We get 0.28930. And on Canvas, whether you put that 0 there or make it a phantom 0 is up to you. It'll give you the same answer, but same answer either way, okay? But yeah, sometimes you're going to have to carry the 1 if you get a 9 in the place value that you're rounding to, the target place value. All right, so what about this one? Let's round this one to the nearest tenths. And so that will be the 2. In the tenths place value, immediately to the right is a 4. So again, we ask, is 4 5 or more? The answer to that is no. So since the answer is no, we'll just keep the 2 a 2. Okay, so the 2, just going to drop that down as a 2. Everything to the left stays the same, whether it's the 8 or the decimal. And everything to the right, we just ignore it. So we end up with just 8.2 on this one. And even on Canvas for the homework, you're not going to want to put these as zeros. I just want to put 8.2 right there. Now, on a problem like this one, because you're going to see stuff like this on the homework, it's important for you to know when it says to round to the nearest whole, it's talking about the ones place value, okay? In fact, I'm going to change this problem. Let's make it 267 right there, okay? 267.590. Now we're rounding to the nearest ones. So that means I would underline the 7, and that is the whole place value as well, whatever you want to call it. Immediately to its right is a 5. So once again, we have to ask the question, is 5 5 or more? And the answer to this one is yes. So add 1 to the 7 in the ones place value. Boom. All right. So let's see. Okay, so let's add 1 to that 7 in the ones place value. 7 plus 1 is 8. And then again, since I did change the problem, I'm going to change this now to 268. Now again, you could say, well, everything that was to the right became zeros. Again, I prefer just kind of cross those out. But remember, with zeros like this, you can make them phantom zeros, which means we get to ignore them. And our final answer here ends up just being 268. Well, there you go. There's our objective. I can identify place values. I can round to any place value, and then I can order any, I guess that should say values. You can order any values together usually from least to greatest.